Hello, I am Eleonora Bianchi and I work at INAF, the Italian National Institute for Astrophysics at the Arcetri Observatory in Italy, and I work mainly on observational astrochemistry. So I will present a talk titled The Astrochemical Trail, Interstellar Complex Organic Molecules Informing Planetary Systems. Despite its complexity, terrestrial life is built from relatively small precursor molecules containing carbon, oxygen, hydrogen, nitrogen, and other small elements. To date, more than 330 different molecular species have been discovered in the interstellar medium, some of which could have served as building blocks for prebiotic chemistry. So to determine whether these molecules played a role in the emergence of life on our planet, we must ask, how does molecular complexity arise and evolve during the process that leads to the formation of a sun and its planetary system? Is this molecular complexity at least in part inherited by forming planetary systems? To answer all these questions, the field of astrochemistry adopts a synergistic approach, combining astrochemical observation with laboratory experiments, quantum chemistry calculations, and astrochemical modeling. So during the talk, I will discuss recent observations of molecular species of prebiotic relevance, including interstellar complex organic molecules and complex carbon-bearing species in solar system analogs. I will also talk you about our current understanding of how these molecules form under the harsh condition of interstellar space. I will particularly focus on the inner regions, so the inner 100 astronomical units of young protostellar disks, as observation of these disks are crucial for understanding the initial physical and chemical conditions at the onset of planet formation. While a chemical reset is expected in regions close to the protostar, a significant portion of molecular complexity in the outer protostellar disk is likely inherited from early stages. So, comparing the chemical complexity observed in early stages of star formation with that found in solar system comets provides observational evidence supporting this inheritance scenario. Finally, I will highlight the main challenges facing astrochemistry in the near future, and I will talk you about upcoming observational facility, particularly in the radio domain, so ALMA Band 2, SKA, and NGVLA, in investigating the chemical complexity in planet-forming regions. Thanks a lot, and I'm looking forward to tell you about all of this on April 1st. Thanks.